Hey everybody, good morning. Jim Davis from Fluke Networks here. Today we're going to be talking about a simple but a common topic. Is the cabling good? Because it turns out that the cabling is often blamed for problems. Today we're going to be talking about some simpler testers, the MicroScanner, and our new LinkIQ tester. But before we do that, let's mention my artifact for our demonstrations today. This is going to represent the cabling, the part that goes underneath your desk and the part that goes to the patch panel. Now, when this was first installed, you followed the guidance of the standard and you certified it. You tested it, perhaps with our Versive 2. It's been out since 2018. It's fancier than the Versive 1 because it has a wireless chip in it. And you probably used a DSX 5000 or a DSX 8000 to certify your cabling against Category 5E or Category 6 or even Category 6A. We're not going to talk about this today though. We're going to talk about a simple issue. I've been tasked with plugging in a new widget, a wireless access point, a new monitor on the wall, a new workstation for the new employee. So we know that our cabling's good, but we want to make sure that we're plugged into a switch. The IT department assured us that there is a switch on the other side of this cable. So I'm just going to take off the hat. This is the MicroScanner PoE, so it doesn't have the coaxial port, but it will test PoE levels. And we're going to plug in. Now, this wouldn't be very fair if I didn't plug a cable going to my switch on the far end, so let's plug that cable in. Now, I don't even have to touch anything, and it's telling me that this cable is open 22 feet away. One thing that I'm really curious about is if the wire map is correct. And because this is open on the far end, I can't tell if all of these conductors are terminated. Maybe one is open right here. Maybe one of the pairs is flipped. So I'm going to use this, the technical term is hat, but we'll call it a terminator. We'll plug this in. I don't even have to push a button on the tester. We still are 22 meters away, but look at that. It says caution. Conductor number 4 looks like it's open. We can tell a short distance. Now, that's very helpful. It's open on the near end, not the far end. Well, we could fix that problem, or what if we needed to find the far end of the cable? Let's switch over and tone out the cable. You can use any inductive probe. I'm partial to our IntelliTone and the 200 model of the IntelliTone that has this wire map port on the bottom. So I'm toning the cable. I'm just going to turn this on and check. Yep, this is the cable. This is the cable. So I can find the far end of the cable. And now I'm going to switch it over to this cable map position. And sometimes the signal is still going to bleed over. It's going to be on one of these couple of ports of the patch panel. But because I have this port on the bottom, I can plug into it and oh, remember conductor number 4 was open. Without going back to the far end, I've been able to make sure that I'm on the right cable, and it's telling me there's a problem. Okay, I know there's a problem. Let's stop with that. And let's fix our problem. We'll take out this bad cable, and we'll put in this hopefully good cable. You know how we'll know this cable's good? We're going to test it. Oh, surprise, surprise. All right. So we'll plug that in, and let's plug into our switch for real here because we've seen that the cable is about 22 meters long. And now, hey, look at that, 10, 100, 1000. We're plugged into a switch, and the switch is offering us 10, 100, 1000. Let me show you one other fun trick with the toner here. On many cables, tone please, even though we're attached to a switch, we can still tone out the cable and follow it to the switch because of the fancy digital technology that our engineers put into this IntelliTone. All right, enough with the IntelliTone noise. Now, one other thing that I wanted to look for is this switch offering me power over Ethernet? Now, the way that power over Ethernet works is the switch is going to advertise or offer power over Ethernet, and we're going to listen here and see that it's offering us class 4 PoE. And that's about all that we're going to do with the IntelliTone. Now, I'm sorry, that's about all that we're going to do with the MicroScanner. And we can see that the MicroScanner is very capable. It told us the distance to where the cable is open. It told us when we had a defect in the cable. We were able to tone the cable out. It showed us that we're attached to a switch on the far end, and it's able to tell us about the power over Ethernet. Wow, Jim, that's just about everything I could ever want to know about a cable. But wait, there's more. Let's take a look at our new LinkIQ product. So we'll just get our trusty MicroScanner out of the way here. And, well, we've seen this layout of the cables. How about if we tried a different mixture of cables? So what is it that the LinkIQ can do that the MicroScanner doesn't do? So looking at the menu here, I want to draw your attention. We have two sets of tests. We have copper tests and we have Wi-Fi tests. Wi-Fi tests we'll save for another day, but we could certainly look at the wireless environment in the room that we're in the spot where somebody's having trouble, to see if the wireless is working there. There's no 6 gigahertz wireless in this room. If we go down to 2.4 gigahertz, yeah, we're going to see a couple of access points. But again, that's another story for another day. Right now, we're going to take a look at the copper tests. There are 3 options: auto test, switch test, and cable test. Please, always start with auto test. Let the tester decide whether or not there is a switch or anything on the far end. So again, the same thing. It's telling us the cable's open about 22 meters away. That's good. Now we could use the same hat from the MicroScanner, but LinkIQ is fancier. Well, it's about the same amount of fancy. It has a series of remote IDs. It comes with remote ID number 1, and you can get up to 6 additional remote IDs. Perhaps you have some cabling that's completely unlabeled. Having multiples of these remote identifiers will help you to identify your cabling faster. Now, that doesn't work, so we're going to just slap this coupler here on the end. And I'm going to back up for a moment. I'm not going to save this. Okay. And again, I'm going to push auto test. Now here's where we start to see how LinkIQ is different from the MicroScanner, because LinkIQ is an excellent cable tester. And what it's going to do is tell us the speed that this cabling will support. It doesn't tell us whether it's category 5E or category 6. That's our friend Versiv, DSX. But the speedometer tells us whether we can go at 10 megabits, a gigabit, or even up to 10 gigabits. Now, the way that it measures this is through the parameters that are required. We're measuring signal and noise. And the standards tell us how much signal we have, or insertion loss, and then it measures 2 noise parameters. It measures near-end crosstalk, which is interference from one pair to an adjacent pair under the jacket, and something called return loss. Return loss are reflections that come back on the cable when we get impedance variations. So based on the amount of signal and the amount of noise, we can measure how fast you should be able to connect on this cable with this handy speedometer. Now I have it set to 100 megabits, pretty low threshold, and not only does it do 100 megabits, but this cable would support all the way up to 10 gigabits. That's not saying that this is a category 6A cable. It's a fairly short cable, only 22 meters. So the signal is very strong relative to the noise on the cable. Now, another interesting feature of LinkIQ is we can save this test result. We can't save the test results on MicroScanner. Sometimes it's very helpful to save the test results. You have something you can deliver to your customer to show the customer that you've done the work. Or maybe you're the boss and you're sending your technician out to the field and you want your technician to install. It's a small office. They have 5, 10 drops. But that's been tough with your technicians, and you want to make sure that they installed 5 or 10 drops and that they got the wiring the right way. So we'll just put in a cable ID. Look at this nice big keyboard that we have here. We're doing cable testing 101 today, and it auto-incremented to cable number 5, so we'll hit OK, and we'll save that. Now, we'll download those results to the same linkware that we use with Versiv to manage our test results. All right, we've seen how it works on a good cable. Hey, let's plug into the switch and see what this will tell us about the switch. So I'm just going to remove the terminator here, plug into my trusty switch. Now, I'm not going to change anything in the configuration. As I mentioned, I want to push auto test, and we'll let the tester decide. And the tester said, hey, I see an active device on the far end. It doesn't matter what type of active device. It could be a wireless access point. It could be a laptop that it's plugged into. We happen to be plugged into a managed switch. So because we're plugged into a managed switch, the switch is going to tell us some information. And the information, very useful that the switch is going to tell us, is not only are we attached to a switch, very basic stuff, but it's offering us 10, 100, 1000, and half and full duplex. Just your luck, somebody configured the device on the far end to be 10 megabits half duplex. You didn't know, you couldn't connect. Simple stuff, but these are things you can solve, things you don't have to call in an expert for. Now the other useful thing, I'm just going to tap up here where it says G5, because this is a managed switch through Link Layer Discovery Protocol, LLDP, or through CDP, the switch will tell us information about the port we're attached to. So this switch happens to be named Marysville Data Center, just up the road here, and we're attached to port number 5. I'm sorry, this is a simple home networking switch. It doesn't have VLANs, but if we did have a VLAN, we could see what the VLAN configuration is for the port. Additionally, we can see the IP address of the switch. Now that's very helpful because if we are in the wrong VLAN, we're installing a wireless access point and we are attached to the production network. Ooh, don't want to get those two mixed up. I can call the IT department and say, hey, IT department, this switch with this address, this port, please move it over to the widget, the widget VLAN, yes, a technical term, that I'm supposed to be attached to. All right, what else can we see about this switch? Well, we're going to try and send a ping. We failed to send a ping. I know why we failed to send a ping. I don't have a router attached to it, so we weren't able to get to the outside world. Now, let's take a look at that PoE information. Before, we saw very basic that the switch was offering class 4 PoE. Hopefully, it's still offering class 4. It is offering class 4 PoE. Now, in addition to measuring what the switch is advertising, that the switch is advertising class 4, we're going to do a load test. So we're going to tell the switch, give us that class 4 PoE, because I want to make sure that the switch isn't oversubscribed or some type of high resistance aluminum cabling got put in by mistake. So we have a green check mark there. Not only is it offering class 4 PoE, but we were able to get class 4, which happens to be 25 watts. All right. And let's save that test result as well, because we're going to deliver that to our boss and tell the boss that we got the work done. All right, that is some of the basic testing that we were going to do. Let's take a look at some other types of problems that we might come across. Get rid of our good cable and go with one of these mysterious patch cords. Again, my cabling was certified. My cabling is good. But perhaps this patch cord was handmade and they didn't use a factory-made patch cord. You really want to use a factory-made patch cord because it will work better. So we'll plug this in. Now I need the terminator again to make sure that all of the pairs are terminated. I don't have one of the pairs that are inverted. We're going to push auto test and let's see what it tells us. Oh no, we have failed wire map. Now this is a really insidious wire map because if you look, 1, 2, 3, 6, 4, 5, 7, 8, 1, 2, 3, 6, 4, 5, 7, 8, the pairs are in the right sequence, but we have a problem here called a split pair. Now if we use a very simple LED battery connection makes the light go on tester, it won't notice the problem with this cable. The problem with this cable is that say we have the blue pair and the orange pair, we switched the solid or the striped conductor, so the cable is no longer in pairs. I'm sorry, I can't twist my fingers up enough to show it. But please appreciate that what this means is we don't have pairs anymore. Pairs are the magic that allow us to work. They stop the signal from being radiated to the outside world, and they also have a way of canceling out noise that may be induced onto our cable. If we don't have pairs, we're not canceling out the noise, and we're not going to be able to communicate. So nice of the tester to show us that we have a split pair here. Let's see what other kind of interesting failures we might have. I'm not going to use this cable because we're pretty familiar with it and we know how it's working. What I'm going to do is grab this conductor over here. And let's use our good working black cable to go on the, actually we don't need anything on the other end. Take our terminator and we will plug our terminator into the far end of the cable here. Let's save this failure because we're going to talk to the boss about buying patch cords that are made in the field instead of factory made patch cords. And again, we're just going to push auto test. Oh, yes. That X is not a good X. Oh, look at that. We could run 10 megabits on this because we're only using the 1.2 and the 3.6 pair to do 10 megabits. It won't run 100 megabits. And why not? Oh, insertion loss. Again, not just continuity, but we're measuring the signal strength and the noise. This cable at 108 meters, would that pass or fail? You can answer below. We'll have a little contest. Now, it is failing for insertion loss. We're losing too much signal over this cable. Now, also, it's pointing out that we have a flipped pair. So, a little bit of free technical advice here. We've seen how we can find the distance to where an open is on the cable pretty easily. But a flipped pair, how can I tell whether it's this end or that end where somebody miswired the outlet? Well, I have a little secret for you. If I'm the one doing the installation, it's definitely on the far end where the problem is, where they have the flipped pair. Well, the guy from Fluke told you that's what it is. Kidding, of course. All right, so if we have a flipped pair, we're going to have to flip it back and we're going to have to get some weapons out. So let's take a look at this outlet. And it's telling us that it's the 7/8 pair. So we'll go to the 7/8 pair, the brown pair. Boss, I'm looking at the 7/8 pair and it looks like it's wired correctly. No, the Fluke guy said that it's definitely on the other end where the problem is. Normally, I wouldn't be the one on the other end who has to try and fix this. So we'll just get our trusty hook in here. We'll pull these out and hey, the boss is always right. So if the boss says to switch the striped and the solid, I will disregard what the little sticker on the side of the outlet is telling me. Let me see if that's long enough. If that's long enough to thread in there. You guys do not want to see me trying to punch down cables because I am not actually a professional cable installer. I am going to close this hook before I punch these down because, yes, there's a story about somebody who got the hook caught in their nose as they were punching it down. Make sure I have the blade on the outside. That will also prevent us from having to show our, show our open problem again. There we go. And let's put this terminator back in there. I'm going to save this failing result because I'm going to tell the customer, good thing you called me to come out and fix your cabling because you did have a problem. We'll push auto test again. Still 108 meters long. Will we pass? Oh no! Well, I've set the limit to 100 megabits, but again, cable is too long, so it's not going to support 100 megabits, much less 1 gig or 10 gig. But it would support 10 megabits Ethernet. One of the challenges of using overlength cables. Of course, the LinkIQ, just like the MicroScanner, will generate a tone. Here in the copper menu, I have this little wrench. That's my tool. I can blink the port light, so I can cause the port light to flash on the switch, but I'm going to use my tone generator. I can send either an analog or that fancy IntelliTone digital tone down the cable and check and find out, yes, this is the cable that we're attached to. Okay, so we have heard the importance of certifying your cable in the first place with the Versiv 2, the wireless chip inside of it, using a DSX 8000. Now, for day-to-day simple problems, opens, complex problems like split pairs, we can use the MicroScanner. The MicroScanner also told us if there's a switch on the far end. better, fancier, stronger, faster would be to use the LinkIQ, and some of the key benefits of the LinkIQ, it'll tell us what speed our cabling can support. It will tell us which port of the switch we're attached to, and also this is our least expensive solution that will store test results so you can deliver a report to your customer. My name is Jim Davis. Thanks for joining us here. Questions from the TAC.